about variables and expressions. Our goal for today is to write algebraic expressions. Now what that means is to go from a sentence to an actual mathematical equation or expression. So, when we are looking at words, we need to decide what operations we can use. So for addition, the words that we can use are add, sum, more than, or increase by. For subtraction, we look for the words subtracted from, minus, less, less than, difference, or decrease by. For multiplication, times, product, twice. You could also use 3 times, 4 times, right? Or of. Division, we've got divided by and quotient. We also need to look for certain words that we can just use to describe the following symbols. So here we have the equals symbol, right? And we would use the word is or is the same as. The greater than symbol, we would use is greater than or is more than. The less than symbol, we would use is less than. The greater than or equal to symbol, we look for the words is greater than or equal to or is at least. The less than or equal to symbol, we use is less than or equal to or is no more than. Okay? All of these words, notice that they have is in front of it. That's how you can tell the difference between an operation and a symbol. Okay? So let's try some examples. Here, we're translating each verbal phrase into an algebraic expression. So A says the sum of a number and 12. Well, when you see the word number, it doesn't tell you what number it is. When we're not sure what number it is, we replace it with a variable. So we've got some number and 12. The word says the sum. Well, if we go back, we have sum underneath addition. So our answer would be x plus 12. Now here we have 14 plus a number. Again, we see the number 14. We see plus, which is the word for add, and some number. So this is 14 plus x. 22 increased by a number. So again, we've got the number 22. It says increased by, so that's a plus sign, a number. Well, the unknown would be a variable x. The difference of a number and 10. Difference now, that doesn't mean to add, difference means to subtract. We've got number, some number, and 10, and it's the difference, so we're subtracting it. Notice that the x goes first because the number went first in a sentence. Right? You always follow the order the way it goes in the sentence. So a number minus 3, we have a number minus 3. 14 decreased by a number, 14 minus a number. Okay. Now here, G, we have the product of a number and 8. Well, product means to multiply, so we have x times 8. Now that's a little dot, right? That means to multiply. We usually don't use the x or the symbol right here anymore because we're using variables and we would get confused. Now here, 4 times a number, 4 times a number. 1/2 of a number. Now 1/2 is a fraction, right? But the word of means to multiply. So we have 1/2 of a number. Twice a number means 2 times a number. So 2 times x. Now notice I didn't put the symbol in between the 2 and the x. That's okay. When you put two numbers directly next to each other with no symbol in between, that means to multiply. Now K says the quotient of 3 and a number. Well, quotient means to divide. So I have 3 divided by a number. Now L actually actually says 5 divided by a number. So 5 divided by a number. Now for M, N, and O, these are a little different, right? This says 22 more than a number. When you see the word than, okay, that's going to be a signal that you are going to need to switch around what you write. If I say, I have $22 more than Jerry, and Jerry has 20 bucks, you would say 20 plus 22. So when you have more than, instead of writing 22 plus x, you flip it around and the second term goes before the first one. So it would be x plus 22. The same thing happens with less than. To less than a number, yes, we would normally think 2 minus x, but if I said I had $2 less than John, and John had $10, you wouldn't do 2 minus 10, because then you get negative 8. You would do 10 minus 2. So you flip it around. This is x minus 2. 10 subtracted from a number, that is another one. 10 subtracted from. When you see that from after it, you need to flip it around. It would actually be x minus 10. Now, here we've got mathematical sentences. We can see that it's a sentence because we've got a period after it. Usually with those, you will have an equal sign or an inequality sign. So if I look at A, it says the product of a number and 10 is the same as 40. That is shows you that this is a symbol. Is the same as means it's an equal sign. Now over here, we're still going to do the same thing we normally did. The product of a number and 10 means we're taking x times 10 is the same as 40. So we have x times 10 equals 40. Now B says the sum of a number and 2 is at least 50. That is, again, signifies a mathematical symbol. Now, is at least means greater than or equal to. Now, sum over here means plus. We're adding a number and 2, and that's at least 50. So x plus 2 is greater than or equal to 50. Now here, 1/3 of a number is greater than 12. Here's that symbol again, because we've got the word is in front. Now over here it says 1/3 of a number. So I know I'm taking 1/3 times a number, and that's greater than 12. Here, the quotient of 25 in a number is no more than 8. The quotient, so that means divide, of 25 in a number is no more than 8. Is no more than, if you go back to our list, is less than or equal to. So I'm taking 25 divided by a number is no more than, so less than or equal to, 8. And then the last one in this set of examples, 5 less than a number is less than 5. Notice how we have basically the same words, less than, less than. The difference is this has an is in front of it. This is our mathematical symbol, is less than 5. Here, less than is an operation. That one doesn't have an is in front of it. If we look back at our operations, less than means minus. Now, if you have this down, that's really close, but remember, in subtraction, if it says less than, more than, or subtracted from, that means you need to flip it around. So I have x minus 5 is less than 5. All right, we're almost done. So here, we've got more examples. Now, these 5 examples we're going to do together in class tomorrow, so you can go ahead and skip those. Now, let's go to some tables, right? Now the directions say to write a rule in both words and as an algebraic expression to model the relationship from a table. So it says, while on vacation you rent a bicycle. You pay $9 for each hour you use it. It costs $5 to rent a helmet while you use the bicycle. So here it's showing us, if you rent the bike for 1 hour, it's going to cost you 9 times 1 plus 5. That plus 5 is there no matter how many hours you rent the bike, because that's the cost of the helmet.
Mr. Rudiger, please call 3121. Mr. Rudiger, call 3121.
Sorry for that interruption. Right. So here, I have for 1 hour, it would be 9 times 1 plus 5. If I rent it for 2 hours, it would be 9 times 2 plus 5. And this number is going to change because that's how many hours you're renting the bike for. If you only rent it for 1 hour, it's going to be $9 plus the 5. If you rent it for 2, it's going to be $18 plus the $5 for the helmet. Rent it for 3 hours, it's going to be $27 plus the $5 for the helmet. Right? If we want to generalize this for if you don't know how many hours you're going to actually rent the bike, we replace one of these numbers with a variable. Notice the 9 and the 5 stay constant. $9 an hour plus the $5 for your helmet. This is what changes. So if we're unsure about the number of hours we're going to be renting the bike, we're going to keep the equation the same, 9 times plus 5, but since our unknown is the number of hours, we replace that with an n. Okay? It's our unknown. Now again, I told you I don't really like the x as your time symbol, so when I write it, I'm going to do 9 times n plus 5. Now you technically don't need the parentheses in there, but that was in our original table, so I left it in. So this is mathematical symbols. Now it also wants to write a rule in both words and symbols. So words, I would write 9 times a number, because that's our unknown, plus 5. And that's it. Okay. So let's look at the second example. B says, at a shoe store, a salesperson earns a weekly salary of $150. A salesperson is also paid $2 for each pair of shoe he or she sells during that week. Now this one doesn't have the table filled in like the last one does, but that's okay. Right? No matter what, this salesperson earns $150. But they get paid also $2 for each pair of shoes he or she sells. So if they sell 1 pair of shoes, they're making 2 times 1 plus 150. So they're making $152. So if they sell 2 pairs of shoes, it would be 2 times 2 plus 150. If they sell 3 pairs of shoes, that would be 2 times 3 plus 150. So you get the idea. The $2 per shoe that you make doesn't change, but if you sell 1 shoe, you add $2. If you sell 2 shoes, it would be 4. If you sell 3 shoes, it would be 6. If you sell 4 shoes, it would be 8, and so on. So our general expression, okay, when we have an unknown number of shoes they sell, would be 2 times n plus 150. So our expression in mathematical symbols would be 2n plus 150. In words, it would be 2 times n, or a number, I should say, plus 150. Now, that concludes our first lesson. If you have any questions, make sure you note that in the Google Doc below that you need to fill out. Okay? I will see you all tomorrow.